Hi everyone, welcome to Vidyalakshmi YouTube channel. This is Naresh Reddy Chemistry in Vidyalakshmi School, and last two videos we discussed about the coordination compounds introduction and who first discovered the coordination compound, the Werner and Werner theory, and another video we discussed about some basic definitions of coordination compounds, right? So in this video, let us go to how do we give a name to the coordination compounds. Okay, right. So let us go to our concept, that is nomenclature of coordination compounds, right? So how do we give name to the coordination compounds? In last video we discussed that coordination compounds are nothing but complex salt, right? So why we are calling those as a complex salt means when they dissolve in water, they produce few ions only, but not all. Okay, since we are calling these coordination compounds as complex compounds, we can say that is we can give the name to these coordination compounds like that of our simple salt. For example, NaCl, if I am taking it is a simple salt, how do we give the name to that? Means sodium and chloride, right? Sodium chloride. On that, if I am taking that NaCl, in this NaCl, Na plus and Cl minus is there. So name of this one is sodium chloride, right? So here which name we are writing first from that salt? Means sodium plus means cation name we are writing first, and after that anion name. So cation name and after that anion name. So when we are going to write down the complex compound names also, we have to go like this only. First we have to write down the cation name of that complex compound, after that anion name of that complex compound, right? So to write down that cation name and after that anion name for the complex compound, we have to follow some rules. So before going to discuss that rules, let us see two examples of complex compounds. Okay, so what are those two examples? Means I am taking these two. CONH3 taken 6 Cl3. This is one type of complex compound. Another complex compound I am taking K4FeCN taken 6. K4FeCN taken 6. Okay. Another compound I am taking K4FeCN taken 6. Okay. If we are observing these two complex compounds, and last video we discussed that in a complex compound, whichever kept inside the square bracket, that we call as a complex ion, and outside square brackets what we are writing, that are counter ions, right? So here this potassiums act as a counter ion and this FeCN taken 6 collectively act as coordination pair or complex pair, right? Now in this chlorine act as counter ion and CO and 6 ammonias together collectively called coordination pair, right? Now in this, whatever the counter ions present left side of the square bracket, those behave as cations. So that this entire coordination pair act as anion. So when we are going to write down the name of this compound, first we have to write down the cation name potassium, after that we have to write down the coordination pair name because it is anion, right? Now like that, if I am taking here, this one act as anion because they are present on the right side. If any counter ions are present on the right side, that act as anion, and coordination pair act as cation, right? Coordination pair act as cation. Is it clear? Now, so in this compound, first we have to write down the coordination pair name, after that counter ion name. When we are going to write down the counter ion name, whether it is cation or anion, no need to write down the repetition of that number. Just that name only we have to write. Okay? Clear? Right. Now let us go to how do we write down the coordination sphere. Counter ion, how we write to means, as usual general name what is there, that name we have to write without a repetition of the number. But when we are going to write down the counter ion name, whether it may belongs to either anionic state or cationic state, how do we have to write down? Means, in that coordination sphere, two types of terms are there. One is ligand, another one central metal atom, right? So here, in this cobalt act as a central metal atom and 6 ammonias act as a ligand. In this iron act as a central metal atom and 6 cyanide act as a ligand. So except metal atom, whatever present inside the square bracket, those act as a ligand, right? So when we are going to write down the coordination sphere name, we have to write down first ligand name, after that central metal atom name. Okay, so first we have to write down ligand name. Ligand name we have to write first. When we are going to write down the coordination sphere name, whether it is anion or cation. After that, central metal atom name. Central metal atom name. Central metal atom name we have to write. After that, we have to indicate the oxidation state of that central metal atom in bracket. Okay, this sequence we have to go to write down the coordination sphere name. Ligand name, central metal atom name, and after that oxidation state of that metal atom in parenthesis. Bracket means parenthesis in Roman number. That oxidation state we should represent in Roman number, not +1, +2, +3. We have to write down as 1, 2, 3 in Roman numbers. Okay, now clear? Right. Now, when we are going to write down the ligand name, that complex compound may have similar type of ligands or different type of ligands. Right? Similar type of ligand means homoleptic, different type of ligand means heteroleptic complex compound. If similar type of ligands are there, then no problem. If different type of ligands are present, then in alphabetical order, which ligand name come first, that ligand name we have to write down. Okay. For example, if I am taking one ligand present as a chloro, another ligand present as a bromo, then in alphabetical order B come first, after that C. So first what name we have to write down means bromo ligand name, after that chloro. Okay. This is the one rule we have to follow to write down the ligand name. If different ligands are there, then according to alphabetical order we have to write. Okay. Whether same type or different type, whatever may be. If same type or different type, whatever may be, when we are going to write down in alphabetical order, we have to represent that ligand repetition number also. Means how many ligands are there, that number also we have to represent. For example, if I am taking here, ammonias are present 6. So that this 6 repetition also we have to mention. That repetition we can give how means di for 2, tri for 3, 4, tetra for 4, okay, and penta for 5, penta for 5, hexa for 6, hepta, octa, nona and deca. Like that we have to write. Okay. So here 6 ammonias are there, so that hexa, and ammonia name we have to give as amine. Ammonia name we have to give as nemine. We will say for which ligands we have to give which name. Okay, na? So here we have to represent the repetition of that ligand. Clear? By giving the di, tri, tetra, penta, hexa, like that, depending on the repetition number, we have to give any of this prefix before the ligand name. before the ligand name. Okay. Now, if chelate ligands are there, chelate ligands means if your ligand is going to form a ring after binding to the central metal atom. Okay. Those chelate ligands nothing but bidentate or polydentate ligands. That bidentate and polydentate ligands, when we are going to write down, we have to give the repetition as bis, tris, tetra, kis, like that, instead of di, tri, tetra, hexa, penta. Okay. If bidentate or polydentate ligands are there, then we have to represent that repetition as bis for 2 times repetition, tris for 3 times repetition, and tetra, kis for 4 times repetition. Clear? Okay. Now, so these rules we have to follow when we are going to write down the ligand name. If 2 different ligands are there, in alphabetical order we have to write down first. Which one come first? That name we have to write. When we are going to write down in alphabetical order that ligand name, we have to indicate the repetition of that ligand number also. Okay. If that ligand is monodentate ligand or simple ligand, then we have to give the repetition numbers as like this. If that ligand is a bidentate or tridentate or polydentate or chelate ligand, then we have to give the repetition as like this. Okay. Clear? So, these are the rules we have to follow when we are going to write on the ligand name. Okay. Sometimes if a ligand has number as a subscript, for example, if I am taking here PPH3 taken twice, in this PPH3 is a ligand and that number subscript is there, right? If number subscript is there, then that ligand name repetition we have to represent as bis. Okay. And that ligand name we should indicate in bracket. That ligand name we should indicate in bracket, and a repetition we have to mention as like this: bis, tris, tetra, kis. Here 2 times there, so that bis. Okay. And here chlorine also act as a ligand, and 2 times chlorine, that is here PPH3 means triphenyl phosphine. Okay. So, triphenyl phosphine, and that P is there, phosphine, P come, and another ligand chloro means Cl, C. So, C, between C and P, which one come first? C. So, that first we have to write down the chlorido. Okay. After that we have to write down the phenyl phosphine. Clear? But here 3 times there phenyl, so that triphenyl. But here subscript is there, number subscript, so that we have to indicate that repetition as bis, and we have to keep that name of the ligand in bracket. And here this is a simple ligand, monodentate ligand. Name of that one is chlorido, and repeating 2 times, so that dichlorido. Okay. And after that what we have to write? Metal name. Here metal is nickel, so that nickel. After writing the ligand name, we have to write down central metal atom name. That central metal atom is a nickel, so that nickel. And in this nickel present as a oxidation state 2, so that the 2 we are indicating in bracket in parenthesis. Clear na? So, this rule we have to follow when we are going to write down the complex compound name. Now, when we are going to write down the central metal atom name, we have to check whether that complex compound is present in the cationic state or anionic state. In this, complex sphere is present in anion state. In this, complex sphere present in cationic state. If complex sphere is present in cationic state, then as usual name of that central metal atom we have to write down here. Okay. Nickel means nickel, copper means copper, silver means silver, platinum means platinum, palladium means palladium. As usual name we have to write down. Okay. If mercury is there, mercury. If complex ion is present as an anionic state, then this central metal atom we have to write down that name, and name should end with ate. Means if nickel is there, nickelate. If iron is there, ferrate. If cobalt is there, cobaltate. So that metal atom name we are ending with 8, right? So that 8 word we have to add to the metal atom. That 8 indicates that metal present in the coordination sphere in negative complex sphere. Is it clear now? Right. Now, after that we have to indicate the oxidation state in parentheses. How do we calculate that oxidation state? We will see in another video. Okay. So, here now let us see about, here I told if ligands are negative, here I told how do we have to give the name. Okay. During the giving of the name, the ligand name when we are giving, ligands may be negative ligands or positive ligands or neutral ligands, right? If negative ligands are there, then the name of that ligand should end with O. Cl minus chlorido, right? Cl minus chlorido, OH minus hydroxido, Cn minus cyanido, okay? C2O4 minus 2, oxalate. I will show different ligands and the name of those. On those, everything should end with O, right? If ligands are neutral or cationic state, means positive ligands or neutral ligand, then we have to give as usual name except for these ligands. If water is there, aqua. If NH3 is there, amine. If CO is there, carbonyl. If NO is there, nitro. These names we have to give to write down the name of that complex compound. Okay. So, let us see here. Let us see what we discussed here, that is which type of ligand act as negative ligand and which ligands are example for neutral ligand and what are the names of those, and if metal atom present in the cationic sphere, then how we have to give the name, and if present the same ligand in the anionic sphere, then what type of name we have to give. So, let us see that. After that we will go one example, that is in detail example to write down the name. Okay, right. So, let us see here. This we already discussed. Oxidation state we have to represent in a bracket in parenthesis in Roman number. Okay, if the complex ion is cationic state, then we have to write in the central metal atom name as usual, right? But if complex is an anionic state, then we have to write down this central, that is central metal name as 8, means cobaltate, and if I am taking iron, ferrate, like that in negative sphere. Okay. So, let us see with the example what we have to take each one. Okay. So, if you take here, these are the different types of negative ligands. In these ligands, here if any halogen is there, the name we have to give as halido, means fluorido, chlorido, bromido, iodido, like that. Okay, fluorido, chlorido, bromido, iodido. Here each name ends with what? O. Now, if Cn minus cyanide is there, then cyanido name we have to write. If C2O4 minus 2 means C2O4 is their ligand, then we have to write down as oxalato. And if S minus 2 is there, then sulfido. CO3 is there, then we have to write down carbonato. And I am mentioning here charges of those ligands also. Okay, those ligand charges are important when we are going to calculate the oxidation state of metal. That we will see in another video. Right. So, you have to remember the charges of these and name of those ligands. All these are negative ligands, so that all are ending with O. Right. Clear? So, these names we have to write down for that respective ligands, but name should end with O. Let us see what are the different examples for the positive ligands or neutral ligands. Okay. Positive ligand we can take as nitrosyl. If the same NO behaving as a neutral ligand, name is same, nitrosyl. Okay. and this NH3, H2O, CO, EN, NH2CH3 and PH3. All these are the examples for neutral ligands, right? So, how do we give the name for these neutral ligands? Means for NH3 we have to write down amine, and for H2O we have to write aqua, for CO we have to write carbonyl, and for NO nitrosyl, and for En means ethane 1,2-diamine, and NH2CH3, NH3 means amine, NH3 means amine, on that one place of hydrogen methyl is there, so that methylamine, and PPS3 means triphenyl phosphate. So, these names only we have to write down for these neutral ligands. If any other neutral ligand is giving what we are calling as usual, that name we have to write. Okay, right. Now, let us see how do we give the metal name if it is present in the positive sphere or if it is present in the negative sphere. Here positive sphere, or we can also take as a neutral also, neutral sphere. Okay, in positive sphere if cobalt is present, then as usual name we have to write on cobalt, but the same cobalt if negative sphere is there, means square bracket present in the negative sphere, means counter ions come left side and square bracket come right side in the formula. On that case, if cobalt is there, we have to write cobaltate. Okay, like this name we have to write down. For platinum, platinum and platinate. For copper, copper and cuprate. And for zinc, zinc and zincate. Okay, like this we have to give the name. Aluminium, aluminate. For nickel, nickelate and nickel. Chromium, chromate. Mercury, hydrogenate. For few central metal atoms we can give the name in Latin word. Okay, not for all metal atoms, few metal atoms. Like that silver, mercury, sodium, like that metals. Okay. So, here if iron is there, ferrate, it is also Latin name. Okay. And palladium, palladate, lead, plumbate, plumbate is Latin name for the lead. Okay. Ferrate, that is Latin name for iron. And hydrogenate, that is the Latin name for mercury. Right. So, like these names we have to write for the central atom depending on the coordination sphere charge. Okay. Right. So, based on these rules we have to give the name to complex compound. So, let us discuss these complex compound names. So, here first we have to identify what is cation there and what is anion there in that complex salt. Right. I told if counter ions are present right side, then coordination sphere is cationic species. If counter ions are present on the left side, then coordination sphere is anionic species. In this first example, there is no counter ion because nothing is there outside the square bracket, either left or right side. So, that it is a neutral complex compound. Okay. So, no need to write down the that is no need to write down the cation and anion name. Directly coordination sphere name we have to write. But I told when coordination sphere name we are writing, first we have to write down the ligand name. If those are different, then according to alphabetical order. Okay, when we are writing the ligand name in alphabetical order also, we have to write down the repetition number. Right. After that we have to write down the central metal atom. When we are writing the central metal atom, we have to say the charge of that coordination sphere. Here charge is 0, means neutral. So, that as usual name of the metal we have to write. After that we have to write down the oxidation state of that metal atom in bracket in Roman numbers, right. So, like that by following those rules we have to see here. Here giving the name, that is giving the formula as PTNH3 twice ClNO2. Here NH3 is a neutral ligand, Cl negative ligand, NO2 negative ligand. So, these two ligand names should end with O. Right. Here Cl means chlorido, only one time is there. So, that no need to write on the repetition. And NO2 we call as nitrito, and here also one NO2 is there. So, that no need to write on the repetition. But here NH3 we have to write down amine, right? Amine, but 3 times there, so 2 times. So that diamine we have to write. Now these are the 3 different types of ligands are present. Now in alphabetical order, which one come? A, C, N. A come first, after that C, after that N. So that amine name we have to write down first. When we are going to write down the ligand name, we have to indicate the repetition also if it is repeating more than 1. Here ammonia is repeating 2 times. So that name of this one is diamine. We are writing the first ligand names. Diamine. After that chlorido. Only 1 time is there. So that chlorido. And after that nitrito. Okay, alphabetical order of ligands. Nitrito. So that ligands over. Now we have to write down central metal atom name. So what is the central metal atom here? Means platinum. But is it a neutral or negative or positive sphere? Neutral. So that as usual name we have to write. So that platinum and oxidation state of this one is 2. How do we calculate that? We will see in another video. Okay. Now if we take this compound, here C2O4 nothing but oxalate. Only 1 type of ligand is present here, that ligand is oxalate, but repeated how many times? 3 times. So that trioxalate we can write, or trisoxalate also we can write, because it is a didentate or chelate ligand. Okay, so that we can write on this as trisoxalate. Okay, sorry, first we have to write down cation name, right? In this, which one is cation? Means counter ion is present on the left side. So that counter ion is, this counter ion is cation, and our coordination sphere present in anionic state. This entire one is anion state. So first we have to write down the cation name, means potassium. Okay. After that we have to write on the coordination sphere name anion, right? So on that trioxalate. Okay. So ligands over. After that we have to write down central metal atom name, but here central metal atom present in the negative sphere. So that what we have to write? Chromium or chromate? Yes, chromate. So that potassium trioxalate chromate 3. Chromate 3. Now let us see next one. In this, counter ion is chlorine present on the right side, so that it is anion. Then coordination sphere present in cation state. So first we have to write in the coordination sphere name. After that we go to anion chlorine. Okay. So when we are going to write down the coordination sphere, here ethane, that is En, means ethane 1,2-diamine. Ethane 1,2-diamine, name of this ligand. And Cl means chlorido, right? So ethane 1,2-diamine means start with A, and chlorido means start with C. So which one come first? C. So that name we have to write down as dichlorido, 2 times there. So the dichlorido. Okay. And here 2 times ethane 1,2-diamine is there. So that ethane 1,2-diamine we can write, or because it is a chelate ligand, we can write down the bis also. So that bis ethane 1,2-diamine, ethane 1,2-diamine, ethane 1,2-diamine. After that metal atom name, positive sphere, so that cobalt, and oxidation state is 3. Oxidation state 3. And after that we have to write on the counter ion name, that is chloride. Okay. And here you can ask to me, here 3 potentials are there, but why we are not writing tripotassium? I told counter ion numbers no need to repeat. Okay. No need to mention the repetition of counter ion. Just we have to write down that name only. Now let us see this one. In this case, this chlorine acts as a counter ion, and this entire one positive sphere. So first we have to write down the coordination sphere name, after that counter ion name. So that what is the name here means? This CO3 means carbonate. It is a negative ligand with a charge 2, and amine NH3, but 5 times there. So that pentaamine. So name of this compound is pentaamine carbonate. Pentaamine carbonate, cobalt, oxygen state is 3, okay, and counter ion chloride. Okay, now if you see the last one, here mercury is present in +1 charge. Mercury present in +1 charge. So here that mercury is a cation, right? Because left side of the square bracket. So that as is the name we have to write mercury. Okay, after that we have to write on the coordination sphere name, and here SCN is the ligand that we call as thiocyanate, which has 1 minus charge. Thiocyanate 4 times there. So that tetrathiocyanate, mercury tetrathiocyanate. And next cobalt is there but present in the negative sphere. So that cobaltate. Cobaltate, oxygen state is 3. To give the 3 oxidase state, mercury present in +1 state. Okay, that's why we have to mention here mercury 1. Mercury 1, tetrathiocyanate of cobalt, 3 complex compound. Okay, so like that, let us say example for this one. K4 FeCN taken 6. The name of this compound we can write down as, here coordination sphere is negative sphere and potassium cation. So that potassium hexacyanide, 6 cyanides are there. So that hexacyanide, and iron present in the negative sphere. So that ferrate, hexacyanide of ferrate 2. Okay, oxygen state is 2. So like this we have to give the names to complex compound. Okay, so hope you all like this video. So if you like, please share, subscribe and comment on this, so that I will try to upload more videos to you. Okay, so wish you all the best, and we will meet you again in another video of calculation of oxygen state of the central metal atom in a complex compound. Okay, so see you all in another video.